to say take the derivative?
Local extrema.
It asks for local extrema first, right? How do you find local extrema in general? And then, yes, okay, so then you have a goal now. You know what I'm saying? Like, that's your goal. The second part says what of this problem? Increasing or decreasing. How do you do that? Eve? Say the same thing you said last time. What do I look at in this derivative, Marco? For increasing and decreasing. I take the derivative and for increasing and decreasing intervals. And
well, I just look at the graph and see where the slope.
ah, that's for people with fancy calculators and stuff. We're mathematicians. We take the derivative and
plug in x values on each side of the points.
yeah, you can make a little sign chart. Find when the derivative is positive or negative. You know what I'm saying? If you want to find when a function is increasing or decreasing, take the derivative, find when it's positive or negative. If you make a sign chart, if you find where it equals 0 or undefined, then just check to the left and to the right. That's the only time it can change from positive to negative. So, what's the derivative, Eric, of this thing?
2 minus sin x.
2 minus sine x. Looking at this equation, when, Wayman, is this thing equal to 0 or undefined?
It never touches 0.
How can you know that just by looking at the equation, which is tricky to do, but that's what we're working on? How do you know that?
You set 0 and you just subtract.
Oh, that's interesting. Yeah, set this equal to 0. And then if you bring this over to the other side, you get 2 equals sine x, something like that. And when is the sine ever equal to 2? It can't. Yeah, this thing is a sine x function, but with a plus 2. So just wiggle, wiggle, wiggle above the x-axis. So there are no extreme values. And is it ever undefined? No, so that's it. So when is this thing increasing or decreasing? How do I know it's always increasing?
If you take the derivative of any x value, it's always positive.
Yeah, this thing is, since the derivative is always positive, the original function is always increasing. Take a look at this thing. Because you would think with a cos, shouldn't it have some wiggle, wiggle, wiggles? Take a look at 2x plus cos x. Kind of a...
Well, like you're adding the x always times 2 and then you're just adding a little bit.
Yeah, a little bit. Exactly. Does that make sense? Just kind of use it like, I guess, not common sense because it's like hard to do, but like, yeah, just kind of like, okay, well, this is going to be the 2x function with just a little bit, either adding or subtracting. Yeah. So extreme values. Take a look at it. None. Decreasing. Never. Increasing. How can I write this in interval notation for always? Yeah. What did you just do? Oh, that's what it was. I didn't know what that was. So you're doing that. I don't know what that meant. Yeah, all reals. This or all real numbers. Great. Questions on this problem? Did we like it? Brandon, did we like it or not? On a scale of 1 to 78, how would you say would your liking this is? Why not? What's your scale? 10? Lame. Okay, well, I guess. So he likes it 100 out of 78. All right. 16. Give it a try. You really like that one. Good. 16 together. Give it a shot. Really likes it. Does it?